Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. Now I will present our paper, Chitosan from shrimp cellulose as biopolymer in the EOR method literature review with authors me, Baiq Maulinda, Student Master Program of Petroleum Engineering, Faculty of Earth, Technology and Energy, Universitas Trisakti, Mr. Muhammad Taufik Fatadin and Mrs. Rini Setiati, lecturer at Master Program of Petroleum Engineering, Universitas Trisakti, Mrs. Diahrini Ratnaningsih, lecturer at Petroleum Engineering, FTM UPN Veteran Yogyakarta, and Mr. Firdaus, Miss Rohima Sera Afifah, and Mr. Abdi Suprayitno, lecturer at Petroleum Engineering, STT Migas, Balikpapan. In this presentation, I have four content. There is introduction, research methodology, result and discussion, and then conclusion. Introduction. Low sweep efficiency in water flooding causes a decrease in oil production in a well. Therefore, it is necessary to carry out advanced production efforts with enhanced oil recovery in the form of polymer injection. The addition of polymer aims to increase the viscosity of water so that the pressure on the oil will increase and the gain in production will be greater. The development of polymer injection continues to the use of biopolymer for injection because it has advantages such as the material is relatively easy to obtain and its availability is quite abundant in nature, resistant to high temperature and high salinity, and is non-toxic in nature. One of the many biopolymers currently being developed is a biopolymer made from shrimp cellulose. Based on data released by the Badan Karantina Ikan, Pengendalian Mutu dan Keamanan Hasil Perikanan Kementerian Kelautan dan Perikanan Indonesia, Indonesia exported 63,022.66 tons of the fishery products since April 2018, and shrimp is the largest commodity in Indonesia, namely 7,436.98 tons, or around 11.79% of total dead fish product. The large number of shrimp produce causes an increase in shrimp cellulose, which results in environmental pollution. Next is research methodology. The method using in writing this paper is study literature review, where the data obtained is secondary data from previous research. Chitosan is obtained through the process of separating chitin from source. The contain lots of polysaccharides, such as cell of shrimps, crabs, snail, and other shelled animals. Then proceed with the manufacture of the Chitosan biopolymer. The manufacture goes through the stage of deproteination, demineralization, and depigmentation. Furthermore, a characteristic test of the Chitosan biopolymer was carried out on petroleum samples, which would be examined on the performance of the Chitosan polymer. And the last stage is the EOR injection process using shrimp cell Chitosan polymer. Next is result and discussion. There are two tests that have been done. The first test was carried out by Rizaldi Trisaputra with formation water salinity 5,000, 10,000, and 20,000 ppm and Chitosan concentration of 2% and 7%. From the test carried out, not all samples proved to be compatible for use. However, some other samples are compatible for use. From the compatible sample used, it was shown that the use of Chitosan biopolymer was proven to increase the viscosity value of water. As the viscosity of water increases, the pressure on the oil will be better. This is evidenced by the result of core flooding, which saw an increase in recovery factor of 1.7%. The second test was carried out by Muhammad Obi Adianto. One of the tests was carried out using Chitosan biopolymer mixed with black rice jelly. The formation water salinity used was 10,000, 15,000, and 20,000 ppm, and the polymer concentration were 500, 1,000, and 2,000 ppm. The result of this test indicate that all samples are compatible for use, and the viscosity of water increased, so it can be used for core flooding. However, the result for core flooding show a small increase in recovery factor, approximately 1%. And then conclusion, from the two tests have been carried out, the use of Chitosan biopolymer is proven to increase the viscosity of water. This increase in water viscosity can be considered for use in polymer injection process, because the purpose of adding polymer is to increase the viscosity of water, so that the sweep efficiency will be much better and more oil can be produced. This is evidenced by the increase in the recovery factor value. In addition, the use of Chitosan made from shrimp shell can reduce waste that can pollute the environment, so that the shrimp shell waste will have a selling value and a benefit value. Solution: we hope that research on Chitosan biopolymers made from shrimp shell for EOR will continue. Further research needs to be carried out with a variety of tests and more accurate material composition, so that the increase in recovery factor will be much greater, and of course the oil recovery will be greater with a more economical value. That's all my presentation. Thank you for the opportunity and the attention. I'm sorry for shortcoming in this presentation. Wassalamualaikum warahmatullahi wabarakatuh.